Hey guys, Mark here, the developer of Primordial Empire. Today I'm going to do a playthrough of the game, of the demo scenario, and we are going to get all 3 stars, also by popular demand, since lots of people seem to struggle a bit with this one, even to get 2 stars, let alone all 3, because you need to get 200 biomes and 200 complexity for the 3rd star, and admittedly that is a very high demand. It is basically the absolute maximum that this biome here can support. So we're starting off with establishing a foothold for our colony. As you can see up there, we need to grow at least 4 microagaves. I have 6 now because that's what the light around the colony heart can support. I've also started with the grubber burrow, and I've prioritized the minerals. You can prioritize using the attractive pheromone tool. You can prioritize single little particles and also the large crystals, and you can also prioritize your own plants that have some open jobs or open needs that need to be done. Okay, we are actually, this is not the smoothest start ever because I've run into a little bit of a plasma hole. There has been very low plasma, which can happen quite often when you start off, so that's why I always prioritize finding light and fertile ground first, and then establish a large feeding ground for stem cells. So you grow a lot of microagaves, and there is a lot of fertile ground in the light up here. So I'm expanding up there right now, straight away. You can see I also have a feeder hub and mineral extractor going already. And now I'm placing some microagaves here. I'll try to find exactly the edge of the fertile ground. So that's all I can afford right now. And here I'm deactivating actually the differentiation so that I always have one stem cell up here that doesn't seed any plants. That's because if you have a lot of plant blueprints set, you will run out of stem cells all the time because they prioritize seeding plants over survival, I guess. But I'm sending over some other stem cells as well, and when you have long trips you should feed them on the way there, and you can do that either by the feeding tool, the food provisioning tool, or you can also delete, recycle the weaker cells on the way, and then they will also provide some food for the other cells. I'm now placing some vesicle hubs at strategic places, and I'm trying to be a little bit efficient here so that I don't have hundreds of these lying around, because they are actually also consuming plasma. We found some bones here, and that's another thing that you should prioritize first. There are these harvestable clusters of resources that you can harvest with your grubbers, and because the grubber burrows use minerals to place and then for upkeep. Minerals are something that are only really relevant for more advanced plants in the start, so you can use that for the grubber burrows to give you all the other goodies. Okay. Just expanding a little bit more, using all the plants that have been unlocked, increasing storage capacity right away, planting more protein incubators. And with these also you shouldn't go all in right from the get-go, because they consume plasma and you don't have a lot of that until you have a sizable stem cell population. Just doing some fleshing out of the colony up here, expanding towards the left because there is more fertile ground. I have a lost spawn here. That happens when the spawns are traveling outside the eye contact of their hubs, and then they get lost and then they get deleted. And to prevent that, I have just placed down a repulsive pheromone that is selective for just the feeder cells, so because they tend to venture around corners a bit, so to prevent that in the future I have just placed that down there. I'm expanding up here now, and I know that there is more mineral there. We have a negative mineral balance right now. And for that we need feeder cells, so I'm placing a few down right now. I'm not actually activating the symbiotic feeding chain in the microagaves yet. I'm just using the feeder cells for mineral extraction right now. But you can later on click on that in the microagaves, and then you will use the feeder cells to pump more calories into your microagaves that will then pump more food out for your stem cells. But I'm usually not doing that in the beginning. I'm waiting until I have some mineral extractors going. Okay, so there are not a lot of stem cells up there, so I'm trying to extract some. Here there is fertile ground that is in light, and you can use that for microagaves. And then down there, this is actually in darkness, so you can use this for protein incubators. Now this area up here I'm usually using for the enzyme distillery, which will be the next milestone, and that is also something that confuses a lot of people, admittedly due to incomplete tutorialization of these things, of these mechanics. But the enzyme distillery produces a strategic resource, enzymes. And the big difference between strategic resources and stockpile resources, like the other ones, is that strategic resources don't get used up. So you have them, when you produce them, you have them. It's a bit harder to get them, but once you have them, they are actually more simple. They are global, they don't need to be distributed by vesicles, and they don't get used up. And what I'm doing up there is I'm creating a little pocket, you can see it right there up in the corner to the left, with 3 vesicles which are trapped in there. And they are basically, their only job is to constantly feed protein into the enzyme distillery. And that's something that I've seen happen a lot of times in other playthroughs, that the enzyme supply is very intermittent and shoddy. And that happens because the supply setup needs to be very robust for that. So I'm just isolating them up there, and they will only be responsible for supplying protein to the enzyme distillery. And while I explained all this, I'm just fleshing out the colony a bit more, because I'm actually I need to get up to 40 protein before I can place the enzyme distillery. We've discovered the hot zone. Yes, that is also a thing that is not explained at all, but most of you probably found out. That is not a viable region of this biome. You cannot use anything there. There is this amber up there, which is very enticing, contains 20 DNA, but it's actually, you don't have the technology to mine in a hot zone. Your grubbers will all just burst, and it will be a huge waste of mineral because they get constantly cooked and then replaced again, and that needs mineral. So that is more or less just a trap up there. Don't mind that. We've also found a toxic pocket here. This is a lot easier to handle because it's smaller. And now I can actually place down the enzyme distillery, and you will see that this is very close, this is very isolated, and this is now, as you can see, the chain to produce enzymes down to the right there uses a lot of protein. And once this is grown enough, the vesicles will start feeding it. Okay, just using the blueprint mode of the DNA sampler, the genetic sampler, and it will highlight how many polymorphisms you can get at a certain point. And I'm just scanning a little bit and reserving in my head some room for them later. Because that once we get to 100 biomass, and you can see we've reached 75 already. I've not gone into the complexity at all at the moment. I'm just trying to get to 100 biomass, so then we can basically produce infinite DNA, and that is what we use to plant the neurons, which will then grow our brain, which we can use to produce complexity. At the moment, the neurons that will produce complexity are not really used for anything else but to just achieve the goal of this demo scenario. But in a later build, in the full version of the game, this complexity is then used for like a resource, basically. And you can imagine it like this. It's like a brain you are building, and the better your brain is, the more actions you can take. So, for example, there is one category, build category, the rightmost build category, which is empty at the moment, and there is nothing in there. It's the R&D category, basically, and that will be like the science branch of this colony. You can build some plants that will enable you to research more plants and upgrades and stuff, and you will need neuron capacity for that. Complexity, a brain, basically. Okay, I'm expanding to the right now. To get to 100 biomass, we will need to settle this other region to the top right, or the northeast if you want. Doesn't really make sense to call it the northeast if this is a side-on view, but let's go with it anyway. And now you can see I highlight actually I started using or building up a little neuronal network even before we reach biomass 100, and that is because I now have placed down the toxin harvester, and that is what I was reserving my DNA for, because that uses 20 DNA, and you can actually play yourself in a corner if you expand with neurons too early and use up all the DNA of the map just to build your initial neurons, and then you don't have enough to build the toxin harvester, and that could become a little bit uncomfortable, and then it will be very tedious to recover from that. So I'm placing that first, and here you can see it pumping. It's producing toxins. We already have it to the top there, and I'm just blocking off the toxic part of the biome so that the cells don't go into that. And as you can see, I also just used the recycling tool to basically cull some stem cells, the weaker ones, and then they will provide food for the stronger ones, and that is an alternative to using food rations if you don't have any. I'm now using the toxins that we are harvesting to produce light down there. I'm placing a lumiflora, and up here you can see the grubbers are grubbing away at the amber there, and that is actually some DNA that we can use. We can now also plant lancet hives, and I'm doing that in both of our main food production grounds, so that we will be able to remove those pesky wild agaves and replace them with our own, because that will give us biomass, and they are also far more effective. I'm now just trying to figure out where I can place the feeder hub for the mineral extraction zone up there. There is a lot of crystal. You can fit 4 mineral extractors, but you need a little bit of planning for that, so that you have feeders that can actually feed on something but also provide food to the mineral extractors. Also making use of the carnivorous plants here to increase our protein production a bit, because we will need that later. Yeah, that was a misplacement. I remembered this, the region right next to the vesicle hubs is actually prime real estate, because you can grow some plants only there, like the storage units. And that reminds me that I should increase my storage capacity for plasma, because sometimes it just happens that you get into a little bit of a bind with plasma when you expand too quickly, and then it's good to have a little bit of stockpile. Now marking all these wild agaves for destruction. And the lancet cells you can see here, they are very nicely taking care of those wild agaves. And of course, that's at the moment this is the only real purpose of the lancet cells, but in a later build we will have some actual combat going on with these guys, and that is something that is in the works right now. Some combat, defense of your colony. Now here, this part of the map is really well suited for neurons, because, and that is also something that confuses some people, the neurons, and admittedly this is because of lack of tutorialization. It will be included in a future build of the demo. The neurons actually should be as close together as possible and bunched up as much as you can. The thing that confuses people is that there is also a bonus for the longest chain, and some people interpret that as the neurons need to be physically as far apart as possible, because that will produce a longer chain. But that is actually not relevant to the neurons at all. They are just interested in how long is the chain of connections, like how many neurons are connected in a row, and that gives the bonus. But it is actually far more efficient to bunch them up in a little niche where they all stick out into the center of the niche, and then they can connect to one another, rather than trying to produce a long chain. That is more like a bonus. Okay, so now we can produce infinite DNA. The genetic sampler will now sample all these cells here, but at some point he will have sampled everything. I'm saying he, but maybe it's a she. Anyway, it will sample everything, and at some point there is nothing more to sample. So what you can do is you can plant berry grass, and I'm actually deactivating the plasma and protein consumption in these berry grass, so that they are only fed using the nitrogenase chain, which is just based on having enzymes available, and that is basically free. As I said, enzymes don't get used up, you just need to have them for this to work. And it is not very high yield, but what it can do for you is it will constantly produce these berries for free, basically, and they get eaten up by the feeder cells and by the carnivorous protein factory, and then they regrow. And every time they regrow, they will contain a new polymorphism for the DNA sampler to scan. So that will then effectively produce infinite DNA. Okay, now we're ready to expand to the top right there. There is still this pesky crystal in the way before we can recycle the rubber burrows down there. So I'm deciding to explore the little pocket down there. Again, I'm placing some food on the way for our stem cells. And then I see that they are starving on the way, so I'm trying to provide some food, but was a little bit too little too late there. But I got some over, and that's really all that matters. And what we can do here is we can use the stem cell sprouter, because this is really far away from any fertile ground, except if you count the one that we created up there with the lumiflora. But here it is really nice that you can use the stem cell sprouter also for biodiversity, because you should just have one, because it gives you the bonus, and also it will provide a constant source of stem cells. So now first plant the lumiflora to create an area where there is light, and then I'm just marking down where the light will not be with a protein extractor, incubator rather, and then I'm placing the stem cell sprouter in the no man's land between light and darkness, because they just need fertile ground. And then I'm trying to make sure that my stem cells here don't starve too early, because I will need them in a second to produce the microagaves. So now that the lumiflora is almost mature, I'm confident that I can place down these. But they are very easily offended if they don't have any light, and you can see they will immediately complain that they are starving. So you should really make sure that the lumiflora is almost mature before you place them. I'm also just now placing a feeder hub. I'm disabling seeding in this spawn of the stem cell sprouter, just so that this guy doesn't seed any plants, and then you need to invest resources to regrow him. So he will just eat all the food and then divide, and then the daughter cells will seed the plants. Okay, so now we have fleshed out this little pocket here. We can use it for protein production and for plasma production and for biomass. Okay, now the crystal is gone. We can remove these grubber burrows and maybe continue the neuronal network in a second. Just trying to get up to more biomass here and increase the storage capacity also, to give us a little bit of a buffer. Now again, this is just a little barrier that prevents the feeder cells from getting lost up there. And here you can see now this is working quite nicely. Actually, there is not enough vesicles to get all the resources in time, but that's all right. This will just produce DNA whenever someone is ready. We can use a second one here, and here there's no fertile ground, so I'm just disabling that chain so it doesn't produce the yellow exclamation point. Getting some berry grass also for the trick that there will always be something to scan for the cells, because they will definitely get eaten and need to regrow. And here very nicely we can fit in one provisioner bud. Okay, now it's time to expand the neuronal network. And here you can see these two walls are nicely close together, that the top and the bottom neurons can connect, and that will boost up our complexity like crazy. Now this is a little awkward. This vesicle hub unfortunately has to go, because it is right on a cusp there, and that is just a little bit too far for the neurons to bridge. So yeah, need to place the neuron there and then place the vesicle hub right next to it, so we can get as much use out of that area as we can. Now this area here we can also use for biomass increase. You can place a lumiflora right in the middle, and if you manage to get it just right, you can get actually 4 microagaves there. But it's a little bit difficult, and like the placement tool sometimes tends to be a little bit fiddly, so if you don't find the correct pixel basically where you have to be with the cursor, it will not work out as well. But yeah, that's just, at the moment, this is a limitation of the system. Okay, let's flesh out this part here. Now what do we do there? Just trying to find the hotkey for the mineral extractor, and yeah, you can place one here, but it's very awkward because actually there is not enough headroom in most of these locations there, but you can fit one. Yeah, I'm trying to do that. We just see here that the lumiflora has been built, has been growing nicely, and now I'm realizing I don't have enough minerals, so I'm trying to increase that by placing one more mineral extractor down there. Just checking whether I have maxed out as much as possible. This is working nicely here. You can see these vesicles, they are just supplying the enzyme distillery. Okay, so now for this, okay, what's wrong with you? Ah, okay, there is no stem cell, so let's try attract one. Come on, yeah. Move on over. Please seed that plant. And by the way, some people said that, or were sad that the stem cells sacrifice themselves to seed the plants. But actually the idea is, from a biological standpoint, that they don't sacrifice themselves, they become the plant. And it's like this is a strange way of the strange way of microbial life, like in Ender's Game in the second book, when they encounter the little piggies that seem to be involved in a super barbaric ritualistic sacrifice practice. And it's basically, in the end, it turns out. So sorry if this is spoilers. If you wanna still read the Ender's Game book series, then just skip ahead for about a minute here. But in the end, it turned out that the piggies aren't actually sacrificing themselves. They are just transcending into their next form of life, which is actually like cognitively and from their just overall way of being is superior for them. They turn into trees, and they turn into sentient trees. And you can see it a bit like this here. The stem cells, they don't really sacrifice themselves. They just ascend or transcend into their next stage of being. So here there is not really any room anymore for more feeder hubs. I'm just trying to increase the number of feeder hubs now, because feeder hubs and feeder cells actually contribute quite significantly to biomass. And you can see we're almost at the cusp of reaching the second star. And we haven't run into much trouble yet. except here you can see this is just this is starving, even though there is a feeder hub right next to it. And yes, this is sometimes a little bit of a source of frustration. Why are they not feeding this? And I'm actually experiencing this myself right now, even though I am to blame for this system. I'm trying to like call them over and tell them with the prioritization tool, hey, could you please? But it just seems to not work out here, so I'm deleting it. And decided that I will just use this for neurons, because at the moment it looks like the mineral rate is good enough for what we want to achieve. So let's just expand a little bit with the neurons here. If you do it correctly, you can place some here and maybe even loop them back around. No line of sight there for the loop back, but that's alright, that's just one connection. This should almost push us over the edge of 150. Maybe it's even enough already. So here you can see that the scanning is ongoing and is not nearly finished. The other one here is also still scanning quite nicely, so DNA at this point is a non-issue. Mineral, however, that's, yeah, what is using mineral? And I'm just realizing, okay, because DNA is not an issue anymore, I can actually deactivate mineral feeding into the genetic sampler. Because it is on fertile ground up there, so it gets some calories, and it doesn't work as fast anymore, but that's enough, that's okay. We don't need that much DNA anymore. Later, DNA will be used to improve your cells, so it will be a very valuable resource. There will be, as I said, research and development basically, and one thing that you can do is actually, I'm just demonstrating here. Let me interrupt my thought. As you just saw, is you can actually rotate building blueprints. It's not tutorialized, sorry. It will come later. If you press R, you can rotate your build blueprint, and then sometimes that's better because the in-out port or the mouth or whatever the plant has is facing the other way. Anyway, I was trying to say about DNA is there will be mutations and genetic upgrades and evolution and all that, and it's basically going to be the upgrade system. You could research more efficient metabolic processing chains basically, and then integrate them into your existing plants or cells. So for example, you could make you could create more and diverse alternative calorie sources. And now we are actually just about to reach 150. Yes, there we have the second star now. And you can see here biomass mainly coming from stem cells, a lot of microagaves, and also from the feeder hubs. And so that's what we are going for. More, just more. Okay, back to the upgrade system that is planned. You can then basically use your DNA to study and find new genes that you can then integrate into your existing organisms. And that way you can make them more efficient, you can adapt them for other environments, you can, for example, increase their poison resistance, or you can create whole new metabolic chains that they can use so that you can supply them with an alternative source of calories, and that will all use DNA to accomplish. And because DNA is somewhat limited, especially in the early phases of your colony, you will have to decide what you are aiming for. what is most important here. Okay, so this is another little pocket that has walls very close together, which is perfect for a little extension of the neuronal network. And this is not connected to the other part, and that's fine. In real biology that wouldn't really be fine, but in this case it's fine because it's a game and we just need to get the number up. But what it will not count towards is the longest connection bonus. That is being calculated inside the larger network. It is calculated everywhere, but the larger network will just win out, and the bonus will not move because you didn't connect, or I didn't connect the two networks together. Okay, just trying to optimize a little bit down here, so I see that I could fit a berry grass here, but the feeder hub has to go. It has to move over. And it's not a very expensive plant, so you can just demolish and rebuild it. And by the way, you get a full refund when you demolish a blueprint. So if you misplaced something and then you just delete it again, you get a full refund. But as soon as it has been seeded by stem cells, you don't get any refunds. And here I'm just messing around a little bit. I'm trying to simultaneously increase storage capacity for plasma and also create more biomass as much as I can, because as you can see with our little network extension, we have actually reached 200 complexity quite handily. And we are now tasked with the somewhat tedious endeavor of getting to 200 biomass, and I'm just now thinking what I can do here, and just having a look at the colony, what is the best way to move forward. So here there is this pocket, we can use this for something. And what I elected to do here, or what I want to demonstrate, is that you can actually, if you know how to do it, you can actually establish a little bit of a food production and stem cell nursery, even if you don't have light or fertile ground. But you need a very robust supply chain of feeder cells, because as you can see, the microagaves, they can use the feeder cells as an alternative input, but it's more meant as a supplement. Like you should still place them in light and on fertile ground, but you can then additionally pump in more calories with the feeder cells. But you can also try to do it just based on the feeder cells. And what I'm doing here is I'm just creating a lot of berry grass that will supply the feeder cells. And then I have a lot of feeder cells here, and they will then be tasked with just pumping their calories into the microagaves as much as possible. I'm just speeding up this a bit until the feeder cells are ready. And then I'm placing a microagave, but I have deactivated the food production. So it will just grow now. Okay. The stem cell got eaten before you could see the microagave there. Okay, now we're talking. And you can see the feeder cells are mature and full, so they are ready to pump their calories into whatever needs them. And so I can place down these one at a time and be quite confident that they will be fed before they are starving, like you see here. It still complains very quickly, but we will just have to deal with a lot of modifications. So as you see, I just had a little bit of an oopsie with enzymes. So even though I have a very closed system up here, from time to time the vesicles are just not quick enough to resupply the enzyme distillery. And so sometimes you have downtime. So if you want to be absolutely sure that you have enough, you could place a second one, and then you get to enzyme density 2, and then the chances are that you will always have at least one. Okay, now you can see as soon as you basically have 2 full-grown blades of grass or leaves, arms of the agaves, I'm switching on the food production chain. But you will get the occasional starvation alert. I will probably fiddle with the balancing here so that you could actually make this work without it being so annoying, so that the microagaves are a little bit more resilient towards not having food. Okay, I just deleted that one provisioner bud because it was in the hot zone and it would have died anyway. So now I'm realizing, okay, one feeder hub is not enough for 3 agaves, so I'm placing a second one, and I'm actually aiming for 5 microagaves here, and I'm calculating, or I'm reasoning in my head that it will probably be enough. I could of course optimize this more by sealing off the little portal into the fertile ground zone up there, so that feeder cells don't accidentally move up there. And what is that? That's a feeder cell that is stuck in an animation. Something to note down to fix for later. Anyway, if you want to have this system more efficient, you could close it off more with the repulsive pheromone and not allow the feeder cells to go feed anything outside of this pocket, because I think that's what's making this a little bit less efficient than it could be. But as you can see, I just planted down the 4th and 5th microagave that will now just be growing and not producing food for now. And once they are big enough, they are robust enough to survive just on feeder cells. And it's working quite nicely. You can see we are at 188 biomass now. And it's just a matter of minutes until we reach the 200. And I'm actually, I want to show you this without cheesing, so I don't want to just eke out a victory by just like getting over the 200 barrier for a second and then falling back down, because that counts. But what I want to show you here is you can reach 200 biomass and complexity with all positive balances in your resources, so that you could arguably say that this is a stable configuration. And there is lots of room still where you could do something. So I've just used this pocket now. I'm not even using all the biodiversity. I have no grubber burrows now. You could reasonably put one somewhere. We have more than enough mineral balance to support one that is just idling. And it would give you an additional biodiversity bonus point, which will count towards biomass. But as you will see in a few minutes, it's not even necessary here. So here we have some lit areas that you can just use for a little bit of protein storage extension, which gives you also more biomass. So this is just now trying to get the biomass over 200. The last 10 are always the most annoying one. You can see this is quite a bustling colony route now. I have put lots of feeder cells, feeder hubs down and feeder cells, because once there is a very robust colony, you can just increase the number of feeder cells quite substantially, and you will not will not be running into the danger zone of your feeder cells hunting your stem cells to extinction, basically. But you need quite a solid stock of feeders of stem cells. Now I'm just trying to increase the number of food provisions I have. And you could argue that this is a little bit of cheesing, then, that you just pump all the food that your provisioners produced into one of your stem cell pockets. They will eat it, they will divide, and then they will produce a bit more of biomass. But you will see this is actually going to be stable. So just checking, what can I have negative protein balance, so can I increase protein production somewhere? Can I decrease the consumption? So I'm now just trying to find a place where I can plant the carnivorous factory, but I then just decide, okay, let's just disable some protein intake from these berry grass, because they are very, very calorie hungry. Okay, and as you can see, we just hit the goal for a second, but I want to actually get the real 200 there on the screen, and this is it. Cool. Hope this was this was useful for you, and see you next time. Bye.